Things just before I go to sleep. This is today's update. Today's update is I've gone back to doing a simple system without redundancy. Okay. Simple system without redundancy is if one looks at it, there's still LEDs. LEDs will be here, and the switches still the two switches. Okay, the three potentiometers have been replaced by one rotary encoder. The true line LCD has been replaced by a 2.4-inch TFT, possibly 3.2 or 3.5-inch TFT. It's the same interface, just physically bigger. Okay. The idea is that the menus will be stored on an SD card, and as you go through, all your parameters will start. All your menu options will come out. You'll be able to set everything using the rotary encoder, SD card for images, and a user-friendly experience. 12-volt supply, 5-volt supply, ESP32, UART to USB, your output ports, and your and feedback. Okay, this is the design, 115 millimeters by 60 millimeters on a 2.4-inch. Okay. Moving forward, let's go down to this. We have our placement or rough placement of the design. Rough placement of the design. The design is more or less using all the GPIO opens I could possibly find. Somewhat short of GPIO opens, but that's a side issue. You've got a touch screen, you've got a SD card, you've got the rotary encoders, plus everything else that they had on the first version. Somewhat short of GPIO cards, and also I'm still working on a JTAG. Okay, somewhat difficult to set things up. Okay. that was the on the computer. This is everything that I've connected up. We're now looking at a development PCB connected to hardware.
Greetings, it's 12:15. I'm just updating. Here's my ESP development. There's an SD card on the display. Switching off.
When I switched off, it flickered because the 3.3 volts is still connected via the USB. The USB wasn't able to power it up. That's why it kept on pulling down and pulling up the. That's why you had the flicker when I switched off the main power supply.
Switching back on again. One can see the JPEGs.
Okay. JPEGs are your menu items. The setup of the pressure, the BVM, and the rate are all done via image-based menus with a slider and with touch and with the rotary encoder. Okay, that is where we're at.
Okay. JPEGs are stored on the SD card. That's where the menu parameters will be stored for the device. This isn't connected yet. Okay, this is, if I can show you what this is. This is,
Okay,
and
this is the what I've done today. Okay. Over and above this is the Spark Fun. This is the Spark Fun pressure sensor. It's roughly a $50 item if bought via Spark Fun or if bought via Digi-Key. From any reputable source, you're looking at about $50. Roughly about $50. The cheapest I can find in Israel is 180 shekels without VAT. Okay, this device is $10. About. Okay. Contentious issue for me is these two pull-ups. I don't want to go into detail, but I don't like having pull-ups between SCL and SDI and 3 volts and 5 volts. I'm not going to say that I agree with it. I understand Open Collector is able to be used in a higher voltage and it only pulls down, doesn't pull up. Accepted. However, the datasheet says no voltage above VDD can be on these pins. Not my question, not my call. I understand why it is probably okay, but the datasheet says different. Okay, not my call. Okay, this PCB, the circuit is shared via common open commons. It's shared via open source method, which is shared share alike. Okay. I wanted this one. Okay. The circuit, as I said, is about $50 a circuit. Open source. The size of the circuit is 21.8 millimeters by 24.21 millimeters. Okay, what we're looking at here is a matrix, a production matrix, a production panel. It could be called in Israel a chocolate. It's sometimes called a chocolada. Sometimes called a chocolada. Okay, of 20. Before we saw the 25 boards that I made. I made the basically like the slab of chocolate. The slab is the slab is 25 boards, 5 by 5. If I go into the view, okay, surface mount 5 by 5 boards. It's the 3D rendering is not correct. The spaces between the boards get cut out. It's not rendering it correct. But you have 25 boards. 25 boards at $10 a sensor is $250 plus 1 or 2 passives, including pick and place. You're looking at about $13 to $15 sensor, which means that I've approximately dropped the BOM cost via $35 per unit. Okay, it is the PCB is shared via open commons, so relatively obvious that I don't want to use SparkFun logo on the board, but we can give credit that the board was designed by SparkFun. Okay, this in one step has taken $35 off the bill of materials, assuming that this is made not in Israel, and you don't have a $500 NPI for the board, I'm talking about making this board at JLC PCB, and my figures were related to having this board made at JLC PCB. Okay.